Hey everybody, welcome back to my workshop. Today we've got a little something different here. We're going to we're going to try and attempt to repair a Traxxas Easy Peak Dual intelligent charger. So for those of you who aren't familiar with Traxxas, Traxxas is a major manufacturer of higher end RC cars. Well, I guess high end compared to what I had when I was a kid. So anyways, both of my kids are into RC cars, and one of my kids is really into it. So he spent some of his Christmas money on one of the top-of-the-line chargers that they offer. This is called the Traxxas Easy Peak Dual, but this is a charger that is capable of charging 2 batteries simultaneously. It also is capable of charging either nickel metal hydride batteries or lithium polymer batteries, aka LiPo batteries. It also has fast charge capability. It's actually been a very good charger for him. I can't say enough good about this charger when it works. However, one side of the charger is not working correctly. So when I asked him this morning what side it was, he no longer could remember. But it's pretty easy to figure out just with a quick test. So I'll show you. If I plug the charger in, it goes through an initial self-test. So that little light up and light down, it basically does kind of like a self-test or startup. Something goes on, I don't know what. Then it goes to this, which appears normal. If we hook a battery up to the left side of the charger, what immediately happens is it starts to do this. If I unplug this battery, it's a pain that this little adapter comes off, but anyways, if I unplug this battery, you'll notice it basically just keeps acting like it has no idea what I just did. If I plug it into the other side, it does the same thing. But here's what happens when I unplug it. It immediately goes back to this state. This side here, it's almost acting like it still thinks there's a battery hooked up to it. So it almost looks like the left side is the problem side. But what I did is I opened it up, which is pretty easy. Flip the charger over. This charger, oh, by the way, this is a 2972 is the part number. It says model MC-100D, but I noticed that they tend to use this 4-digit number for most of the Traxxas part numbers, which makes it really easy. So you remove the 4 Phillips head screws, and with a little bit of jostling and coaxing, you can get this cover to come right off. And this exposes the circuit boards, and the plugs are right here. So remember now the left side, because I flipped it over, is now on the right. So this is the side that seems to be working improperly. And this is the side that seemed to be working correctly. But turns out I looked at this under magnification and examined it, and actually now that I see it, I don't even need the magnification to see it. You can see that there's some symmetry here. Basically this whole group of electronics right here is identical to this whole group of electronics right here. So it's basically, it's both sides are exactly the same circuit-wise. See this device right here? It's a little 8-pin flat pack integrated circuit, surface mount. Here's its sister component on the other side. And we're going to zoom in on this in a minute. But if we look at this, you see there's some distortion right here. Well, get a load of this. So that's the one on the right side. That is what it probably should look like. This is what the one on the left side looks like. So this is the side actually that seemed like it was working correctly. But you can see basically what's happened here is this, for lack of a better term, this integrated circuit has gone ballistic. And what's most likely happened is when it burned and it fried, it cracked the top of the case open and bubbled out some goodness. So this IC is toast. That thing is garbage. Well, while I'm zoomed in on this, I want to point out something that I thought was interesting. All 4 of the pins on this side, which are pins 5 through 8, because I can see this little dot right here that tells me that that's pin 1. So the pinning goes 1, 2, 3, 4, 5, 6, 7, 8. So 5 through 8, all 4 of these pins right here are all tied together. They're all basically going to this pad on the circuit board. This is actually a copper run right here. So these are all tied together, which is interesting. Also, what's interesting is on this side, pins 1, 2, and 3 are all tied together. At first I thought all 4 pins on this side were tied together, but then I noticed you can just see a little bit of a change in color to indicate that pin 4 right there is actually tied to a pad that is not common to this large pad here. So this large pad is actually attached to 1 through 3. Pin 4 is attached to a tiny pad that goes, basically this is a two-sided board, meaning that this board has traces on both sides. So it's going through the board, through a feed through, to the other side, to a run on the other side, and goes off somewhere else in the circuit. So essentially, there's really only 3 connections happening here. We've got a connection that is going to all 4 of these, a connection that's going to 1 to 3, and a connection that's going to pin 4. So that kind of got me interested in what that device might be, started me guessing what it might be doing. So luckily, the other IC didn't blow up, so I could read the number off of it. I could read that it's an H&M, which is the manufacturer, and it's an HM4410. So I went to the website alldatasheet.com, which is a great resource for if you have a semiconductor and you want to identify what it is and you want to get the specs on it and you want to get the pin out, which lots of times if you don't have a schematic, if you have the pin out on a device, you can actually still do some troubleshooting. So this is a great website. Anyways, I go there and I find an HM4410A, and lo and behold, I find out that it is it's a MOSFET power. I forgot what the description was. I apologize. But anyways, basically, it's a power MOSFET, and what they've got inside this package is, you see, they're showing 1, 2, and 3. Those aren't really the pins that they're referring to there. Because what they're basically doing here is they've got the power MOSFETs, they've got multiple ones inside this little package here. And then by tying these together, you're essentially able to flow more current through this thing, so it can take more power. So they're giving you marking and pin assignments. So look, lo and behold, what are they telling you? They're telling you all the drains are pins 5, 6, 7, and 8. So there you go. That's why those are all tied together, because we're basically just having one drain connection. And then pins 1, 2, and 3 are the source connections. Okay. And then pin 4, remember that's the one that's the only pin that goes somewhere else. That's the gate connection. Okay. So that's going to the control circuit. So basically this thing's flowing power all the way through it, and it's being controlled by the gate connection on pin 4. So that's really all I need to know about this thing. Oh, so the actual name of the device is, it's a 30 volt N-channel enhancement mode MOSFET. And MOSFET stands for metal oxide, hold on, I don't remember now. Well, FET is field effect transistor. So, but who cares, right? All right, guys. Oh, let me just show you something real quick, too. You might find interesting. This is the bottom cover. If you look carefully, you can actually see there's a area right here. Discoloration. Texture is different. There's actually residue there as compared to this side. This is the side where that IC blew. So literally it's sprayed its toxic chemicals and smoke, everything right there onto that plastic. That's literally that's like the spray pattern. If we were homicide detectives, we'd be all over this. And this is a homicide. Basically, this IC was murdered. Probably, if I had to venture a guess what caused the failure, you see these adapters, right? Well, if I accidentally plug this in, okay, I basically have reversed the polarity on that thing, and it probably wouldn't like it. So, it's pretty clear how this should go in, but, you know, unfortunately, my My son may have not noticed it. Or, you know what, the thing could have just given up the ghost for some other reason. And, oh, by the way, the plan here is going to see if we can source this IC and change that IC and see if it fixes the problem. If it doesn't fix the problem, I'm pretty much done with this thing because I can't get a schematic diagram for it. And even if I could, there's a lot of surface mount technology in here that I really don't want to have to deal with trying to unsolder. I'm willing to take a stab at trying to get that IC out because luckily for me, it's just an 8-pin device, and so many of the pins are tied together that I really think I can probably get that out with solder wick and resolder it in with a really fine tip soldering iron. But the problem at hand right now is that a search for the HM4410, other than showing me a data sheet, being able to find the data sheet with all of the specs for this device and telling me what the device is, I can't find one place where this device is for sale. Again, what this device is this is a 30-volt N-channel MOSFET, enhanced mode MOSFET. So enhanced mode, there's two versions of MOSFETs. There's the enhanced mode and depletion mode. This is an enhanced mode. So the interesting thing is, though, I can find plenty of N-channel enhanced mode MOSFETs. Matter of fact, I can even find one that's even beefier than this. That's in a TO220 package, I believe is what they call it, where it's only got 3 pins, gate, source, and drain. And I could literally run 3 wires off of these 3, one off this pad for the drain, one off this pad for the source, and one off that 1 pin for the gate. And I could run those to a remote area, maybe up here somewhere, and figure out a way to mount that larger package and basically turn this into a really durable power supply. And if I was going to do that, I might do it to both sides, run the 2 over here. The problem is, in order for those things to dissipate the power that they're capable of, they should be on a heat sink. And I think I could put a flat piece of aluminum in here that has a couple of drilled and tapped holes, mount those 2 packages on there, insulate the backside with a piece of rubber foam, have that sit right in here where the fan could actually work on taking some of the heat out of that off of those things. And I could turn this thing into a real work of art. But let's not get crazy. This little package here is doing the job just fine on this side, and with a little luck, we replace this, we might be back in business without having to go crazy. Well, I poked around on the Mouser website, and I found an SQ4410EY-T1-GE3. That looked like a stouter version of the IC chip that I want to replace. The package is an SO8 versus an SOP8, which I think means that it'll work. It might just be a little bit thicker, which makes sense because it was a higher current capacity. I think it was a 15 amp as opposed to the 12 amp. It might have had a little bit more power dissipation. But unfortunately, if I order that from Mouser, it'll cost me more to ship it than it will for the actual, for like 5 of them. So I poked around on eBay and I found an plenty of international sales. If I'm willing to wait for a Chinese shipment, I can get these even cheaper, and there's a lot more to choose from. However, I wanted a U.S. seller so I could get these quicker, and I found these here. This is an IRF7413TR. IR means that this is an international rectifier as the manufacturer. It's 10 of them for $8.50, and the shipping's free. So I'm basically paying 85 cents a piece for these. These are N-channel MOSFET 30 volt, 13 amp, so just a little bit stouter. And the peak, the pulse peak amperage is like 96, which is more. Dissipation wattage is like the same as the original spec, 2.5 at the 25 degrees Celsius. So we're going to order these and take a shot at it and see what happens. And those have come in. And it was actually just cheaper to buy them in bulk, so I think I got 10 of them. So the first thing I need to do is I need to desolder the old one. I do not have a SMD type of desoldering setup here. So I am going to use my regular Weller iron and some solder wick, which is a copper braid that when heated over when placed over a solder connection and heated, it tends to have the effect of wicking up the molten solder. So once I get most of the solder, since it's a bad device anyways and I'm not trying to save it, usually find that a gentle twisting motion will pop it free. And I'm looking on the magnification really closely, and I'm noticing if any of the legs do not appear to be moving freely, that's kind of an indication that I need to maybe go back and hit that one again with some heat. Sorry, I was out of frame there. Yeah, it looks like I missed one. Success. In case you're wondering, there is a little white dot on the PC board that indicates pin 1, so that's why I didn't really have to pay much attention to the way that came out. And on the device itself, there's a little dot that indicates pin 1. Now I'm going to go back over the top of this area with some clean solder wick. Finish cleaning that up. These look like that they're kind of running together or bridged, but that's because all 4 of those pins are tied together. This is one pad, so I don't really have to worry about that. Now I'm just going to use some of this GC Electronics flux remover and cleaner. Alright, so now I'm going to tin these little pads with a little bit of solder. I really just need to do a couple on the edge for starters. I think I'll do 2 diagonal from each other. These over here, like I said, they're all tied together. So what I'm going to do now is get some tweezers so that I can handle the new devices. Oh, these are electrostatic sensitive devices. So what I'm supposed to be doing is I'm supposed to not take these out of the bag and handle them unless I have an anti-static mat down and I am wearing a wrist strap that grounds me, because any electrostatic buildup on the surface of my body could damage these devices, is what they're basically warning me about. So in lieu of not having a, I do have a straps wristband somewhere, but I don't know, I haven't seen that in years. So in lieu of that, I'm just going to touch the metal bench here, the frame, and that should dissipate any built up electric charge on my body. Alright, pin 1 looks good. There's pins 4 through 8, be it ever so horrid. 3 out of the 4 are just bonded right to each other. But as luck would have it, in this particular circuit, that's how it's supposed to be. So, as long as I can flow and keep pin 4, which is the only pin that's isolated from on this side from pins 1 through 3. I think I got it. And the trick is to make sure I don't accidentally bond 3 to 4. Oh boy, managed to flow 2 to 3, but 1, 2, and 3 are all tied together. So again, it's not going to be an issue. It just goes to show how bad I am, how out of practice I am. Actually, I wasn't always this bad. Oh, that's soldering. All right, so now I'm going to grab my meter and I'm going to check continuity and make sure that even though it looks like pin 4 is isolated, I want to make sure it is. So I just got a continuity tester. So, like I said, all of these pins are all tied together. And then pins 1, 2, and 3 are all tied together to this pad right here. So, pin 4 shouldn't be. And it isn't. Okay. I have no idea where pin 4 goes. Well, if I had to venture a guess, it might go right to this transistor right here. It does. Alright. Okay, so that's it. The new device is in, so I can slap the bottom cover back on this thing and fire it up and hook a battery up to it and see what it does. Alright, so first thing I want to do is plug it in. As we recalled from, it did this before, but what was different was that when I plugged the battery in that needed to be charged on one side, it acted differently than the other side. Okay, so if I plug this battery in on this side, now it's doing the same thing. Alright, so it does this if I plug into the right, and then if I unplug, it goes back to doing that. If I plug into the left, it does this. But then if I unplug, it stays doing that. I think that's what it was doing before I replaced that part that was blown. It stinks. Okay, so I just did some checks and I have determined that unfortunately my repair attempt has failed. And I'll show you why. I'm pretty sure that's the case. Not only does it do exactly what it was doing before, which is before if I would plug into this side, it would change to that scanning thing, and when I would unplug from this side, it would stay in the scanning mode. And then on this side, it would, if I plugged in, it would go to the scanning, and then when I unplugged, it would go back to this. So that was my first clue. But the real definitive answer that there's still something wrong is when I actually try and charge the battery. This type of battery is an older Traxxas battery. It does not have the ID feature built into it. So this does not have something that tells the charger exactly what kind of battery is hooked up to it and what the charge rate is and everything. So you have to manually do it. So what you do is you plug in the battery to the port and you hold down the charge rate and start stop button simultaneously until it beeps. Now it's asking you what type of battery you want to charge. This is not a LiPo, it's a nickel metal hydride. So I select nickel metal hydride. Now it's asking me to select the charge rate. Right now it's at 1 amp, but I can change that all the way up to 4 amps. So just for the heck of it, I'll put it at 2 amps. And now if I hold this button down until it beeps, it'll start the charging process. And it is now not showing 1 amp charge rate. What it's doing now is it's actually showing me how much is in the battery. So it's showing me it's charging and it's pretty low. As time goes on and the battery takes a charge, more of these LEDs will light up, and when it becomes fully charged, it will beep telling me that it's done charging. That's normal. That's normal operation. Now, I'm just gonna stop it. All right, now watch what happens when I plug into the right side. Same deal, I'm gonna hold down both buttons. I'm gonna select nickel metal hydride. I'm gonna set the charge rate to 2 amps. Now watch what happens when I hold this button down to start the charge. You see what it did? It did the beeps and then it immediately bailed out and went back to this. It's actually completely acting like I'm starting all over again. So again, if I hold this down, select nickel metal hydride, doesn't matter what charge rate. See what it's doing? And now that it's shut the fan off because I'm no longer have a battery hooked up to this side, as soon as I start it, it'll start the fan like it's going to start charging and then immediately shut off. That's it. So the right side's still not working. And this is beyond the limits of my capability here as far as this goes. I mean, I was hoping I would just get lucky. If I had to venture a guess as to what's wrong, I would say, well, maybe that transistor that is tied right to that control pin on that device that was shorted out, that's probably the next thing I would want to look at. But the reality is it's just not worth it for me to go any further with this. So sorry if this is not going to help anybody else out there. Maybe somebody else had the same exact experience and got lucky and replaced that component and everything worked. Who knows? All right. Well, till next time, take care.